All right. Welcome, everybody. This is the Visual Decisions weekly webinar. I've got a very special guest with me today, Frank Costa from Sandalwood Engineering and Ergonomics. We're going to be talking about how to use an open source solution stack to implement IoT for free. With that, I'm going to turn it over to Frank. He's going to run the bulk of the presentation, then we'll have a little bit of conversation at the end. Frank, all you.
All right, thanks, Tim, and good morning to everyone, and welcome to this webinar where I'll be presenting what we're calling our IoT for free technology stack. So just a brief introduction of myself. My name is Francesco Costa, I go by Frank, and I am a manager in Sandalwood System Integration Group, specializing in digital transformation, technical enablement, and implementation. I've been with Sandalwood for over 18 years and have been working in discrete manufacturing space for over 25 of those years. So most of the time has been spent in automotive manufacturing. I did start my career in controls and progressed through the years into what I do today. So I guess the first question is going to be, what is IoT for free? So IoT for free is basically an architecture and a set of tools that will allow anyone to start down their digital transformation path. The idea behind this program is to demystify I-IoT and take some of the guesswork out of an implementation. So throughout this webinar, I plan on going through the technologies being used, including protocols and infrastructure, the base information architecture used to support a basic I-IoT implementation, some open source software solutions that can be used in this stack, and how alternate software packages can be integrated again into the same stack. And finally, we'll close it out discussing potential costs associated with using this technology stack. So why are we doing this? In our daily lives, we typically deal with large manufacturing companies. These are companies that have dedicated staff to address and plan large IIoT implementations and are actively investing and growing in the space. These firms have the resources and money to purchase and maintain SaaS or subscription-based software, as well as cloud-based systems and infrastructure. And most of the time, these cloud-based systems are your typical Azure or AWS-driven systems, but some of these companies have developed their own internal cloud infrastructure and leverage their own coders to develop information gathering and distribution schemes. Now, regardless of how these large firms are executing IIoT, these methods are typically out of the reach of low to mid-level manufacturers. So we wanted to provide a framework for these types of businesses to start down their own IIoT path. We feel lowering the barrier, both with respect to cost and knowledge, to businesses that are planning on executing their digital transformation journey is in the best interest of both not only those organizations in question, but also our team of integrators and consultants. Clarifying how to implement an IIoT solution helps with adoption and integration of these systems. We are confident that once a business sees ROI on these types of systems, additional integration opportunities will present themselves. It's basically a win-win for all those involved. So with that, who is this for? You know, as I alluded to previously, we are primarily targeting small to mid-sized companies. These are companies that manufacture goods and services for some of the larger companies we alluded to earlier. So we're talking tier 2 and tier 3 type companies. That being said, the principles and frameworks I'll be talking about are applicable to almost any size endeavor. You don't need to be making widgets to use this stack. IIoT for free will present a universal framework for data collection, concentration, and content delivery that can be used in any type of business, from machining ahead to for one of the big three to collecting energy information at a greenhouse installation. This stack will also include methods for digitizing your process. So, for example, downtime information can be captured from those machining centers, or quality check data can be collected at those greenhouses. So before we move forward, I want to go through and discuss some of the technologies and terms that we're going to be using throughout this presentation. All of these technologies are open source and can be used free of charge. But there are paid options, both fixed and recurring, that can enhance usability and or support. While discussing communications with the shop floor level devices, we'll be concentrating on using sensors and controllers that support the OPC UA standard. So a little on OPC UA. Stands for Unified Architecture, OPC UA Unified Architecture, which is a cross-platform open source standard for data exchange from sensors to cloud applications developed by the OPC Foundation. Distinguishing factors are standardized data models freely available for over 60 types of industrial equipment, and they're all published by the OPC Foundation. Extensible security profiles, including authentication, authorization, encryption, and security key management. Support for both the legacy client-server communication pattern as well as the newer pub-sub type protocols. And importantly, it's communication protocol independent. So mappings to several communication protocols like TCP/IP, UDP, WebSockets exist. So many of the newer controllers and sensor types support this OPC UA standard. That being said, there is some equipment out there that may be older or have proprietary protocols. I will address some mitigating strategy for those on this stack later on in this webinar. So historical data retention is uber critical for an IIoT system. So when discussing that section of the stack, we'll be concentrating on the SQL type databases. So SQL, or structured query language, is a programming language used to query and manipulate data stored in a relational database. So recently, other types of database architectures have been gaining ground, known as NoSQL or non-relational databases, such as MongoDB. But for this IoT for free tech stack, I'll be outlining a structure that uses readily available, open source, and on-prem relational databases. And finally, we're going to be using something called the MQTT protocol. MQTT stands for Message Queuing Telemetry Transport. Again, it's an open source, lightweight protocol. It adheres to the pub-sub, publish subscribe communication pattern, and is used for message queue / message queuing services. It's designed for connections with remote locations that have devices with resource constraints or limited network bandwidth. It must be run over some sort of transport protocol that provides ordered, lossless, and bidirectional connections. So that's typically your TCP/IP or Ethernet transport. It's important to note MQTT, that protocol is the underpinning protocol for many IoT types of connections. This is a protocol that underpins both the home automation and industrial IoT systems alike. And the MQTT protocol and that message is really just a wrapper for any type of fixed data. So here, just quickly, I'm going to outline our generic tech stack for the IoT for free program. As you can see, the tech stack starts right down at the device level and enumerates all the various transitions. The tech stack is as follows from the bottom up. We have data generation, capture, and abstraction in this layer here. We have data collection acquisition just above it, followed by historical data ingestion and storage, and finally visualization layer or engine, which can be broken out into several subcomponents such as dashboarding, learning and enunciation, and process digitization. So I will elaborate on each of these layers in the next few slides. So starting with at the lowest level, the data generation, capture, and abstraction phase, data is generated by various control systems and or sensors. So this level represents equipment or devices on your shop floor. The raw data from these devices is collected via edge devices. That data connection, those data connections to devices can be facilitated by OPC UA, MQTT, or proprietary types of protocol. As long as you have the proper driver or software, the data should be able to be read. Edge devices will then be used to abstract or normalize the incoming data so as to present a uniform and structured flow of data to higher levels of the stack. So this abstraction layer entails capturing all the incoming signals from the various protocols and converting them into a standard JSON message that is then published via MQTT to an upstream MQTT broker. This ensures that any special cases dealing with the data are dealt with right at the edge. These edge devices can be anything from a centralized server-side machine, Windows-based or other, to single-board computers running Linux. So think of the Raspberry Pis at this point. Implementations using a centralized server will be able to contain the capture, abstraction, and data collection layers all together, and we'll be discussing that data collection layer on the next slide. So the software running on these edge devices can be commercial in nature, developed internally using software packages such as Node-RED or JavaScript, or you can use software that we will be providing on the I-IoT for free GitHub, which will be forthcoming. It's important to note at this point, our code is written in Python and uses 100% open and publicly available libraries, and we'll be providing the base code as well as Docker-based container packages on the GitHub. Please note, because the software uses open libraries, only open protocols such as OPC UA will be supported. So the data collection layer is used to consolidate all the incoming data streams to one single point of contact. Data abstraction can also take place at this layer. This is the natural breakpoint between on-prem and cloud-based applications. In cloud-based applications, the data will be pushed from this level to the appropriate cloud connectors. As previously mentioned, capture, abstraction, and data collection can be combined, but is broken out in our IoT for free stack architecture to indicate that it's not required. This layer of stack houses an MQTT broker that will be used for both raw data ingestion from the previous layer, as well as actual data acquisition, which facilitates both historical and real-time data, and I'll discuss that in a moment. At this point, the data being published to the broker should be presented in a common, abstracted, or normalized manner. So located between the raw data collection and the ingestion layer, the data acquisition layer is used to validate the structure and contents of the data, as well as to filter out non-conforming data streams. At this point, the incoming data streams can be compared to expected parameter norms, as well as rule sets meant to alert end users to abnormal or anomalous data. Valid data is then pushed through two different channels, the historical data channel, which I'll touch on the next slide, and the real-time data stream. For the real-time data stream, the valid data is just published back to that same broker on a different topic that the upper layer can subscribe to. And this again highlights the power of the MQTT framework. As incoming data increases, this layer can be scaled up to include multiple processing nodes, all using the same protocol and infrastructure. For example, if the real-time data stream, it can be published to a different MQTT broker sitting on a device dedicated just for serving up MQTT data. All one has to do is just point the publishing message to that different location. So historical data ingestion, incoming data from the previous level is stored in either a relational or a NoSQL database. And as previously mentioned, I'll be focusing on a SQL or relational based databases. As data flows into the requisite databases, internal processes and procedures can run to segment and parse data based on programmed analytic requirements, such as basic aggregation or associated linkages across disparate data sources. Concurrently, data is also parsed to give context or meaning to the incoming data. An example of this type of parsing includes assigning or linking build unit serial numbers to incoming machine telemetry data. Reporting and data analysis models. The telemetry data should be left unadulterated, as unadulterated as possible, though, to allow for the subsequent data layer, the ability to freely analyze all of the available data. Historical data ingestion can be conducted in both an on-prem or cloud-based environment. So the visualization engine, this is the layer that ingests the data from both historical and real-time channels and pushes it out to data consumers. The real-time channel contains data that is planned to be viewed by dashboard type interfaces. This type of data shows what is occurring in the present with as little latency as possible. While these dashboards may contain data aggregation or calculations, those pieces of data are produced via the historical channel, usually over some time frame or some other attribute that can be sometime provided by the real-time channel. The historical channel is used to aggregate and display data that has already transpired. Think production reports over time, process control charts, birth history reports, etc. Business intelligence or AI models can be applied to this level to combine historical models and real-time information to output decisions based on both. Typically, the historical data ingestion and visualization engine layers are run on two different pieces of hardware in an on-prem environment. So as we discussed, there's a couple ways that the data can be consumed. The first is dashboarding, which is typical front end for users that can be expressed as real-time portals, data analysis dashboards, or potential outputs to other systems. Think of your IoT system feeding ERP data. Learning and enunciation is also part of the visualization engine. Although it can be based on the specific historical data that's been captured. These alerts can manifest themselves as text messages, emails, and of the sort. They can also be made available via specialized dashboards that are meant to be displayed on large monitors or finally, we have.
Hey, Frank.
This is a term I use. Yes.
Your audio is going kind of in and out a little bit.
Is this okay?
Yeah, that's fine.
Okay, I'm sorry. Where was I? Again, this is usually processes. So while process did there, it's the key is that the data is allowing for easier linkages between human input and machine collected data. So on this slide, I've laid out how numerous open source and free software packages sit on the IoT for free stack that I've been discussing. So starting at the lowest layer where we have our data generation, which I've denoted by several devices, all talking using the OPC UA standard. The device capture and abstraction layer is powered by our own open source and freely containerized software written in Python. For that data collection and acquisition layer, you can use Mosquito's MQTT open source broker to support the publishing and subscription of MQTT payloads. And their Python rule sets are used to ensure valid and proper data flow. And as mentioned in previous slides, a real-time stream is being published back to the Mosquito broker for use in subsequent visualization layers, again, consumed on the MQTT protocol. In this example, we're using a PostgreSQL server as a backend database. And on the visualization engine layer, we're utilizing two open source suites. We have Grafana for the real-time portals, historical dashboardings, and enunciation and alerting. And we're using Orbion Forms CE to enable the actual process digitization. So as previously mentioned, any part of the stack can be replaced by software that you may already have, licensed, paid for, or just sitting on your shelf. So for example, you may need to connect additional device types that require protocols other than OPC UA. You can substitute or augment the edge device with Kepware's with PTC Kepware product. In fact, with the proper add-ons, Kepware can be used to replace the data capture, abstraction, acquisition, and ingestion layers. And for that, specifically, you'd use your Kep server, probably manufacturing suite, IoT gateway, and data logger. If your company is currently using Tableau or Power BI, you can just tie those softwares right into the database and only use Grafana for displaying your real-time data. You can go ahead and replace the PostgreSQL server with the Microsoft server or Oracle. It just depends on what paid software you'd like to use. So finally, potential costs. As I said at the beginning of the slideshow, we feel that lowering both the knowledge and cost barriers benefit OEMs, SIs, and consultants. So I've gone through and shown you the stack, and so let's talk about the cost. There's obviously going to be a cost to procuring the right hardware to support the stack. And there's really nothing fancy about this hardware. Standard server type configurations should suffice to get your IoT implementation off the ground. There's also a cost centered around the infrastructure required to make sure your devices are connected. So we're talking Ethernet drops to machines, IDFs if required, and the such. Depending on the size of your footprint, these may not be non-trivial costs, but you don't have to bite off the whole apple at once. By design, the stack is meant to be easily scalable and as such can be expanded when needed. Taking the hardware and infrastructure costs out of the equation, the software costs start at $0. This can be done because you can fully deploy the stack with open source technologies. And because of this fact, this stack can be implemented without any reoccurring costs. And again, open source technologies are great, but they're sometimes not the easiest to configure or work with, and definitely support is a concern. So you may want to pepper your implementation with some fixed cost software, as the aforementioned Kepware. Ignition Edge is another another software package you can use, and again, those can be purchased both with subscription and one-time costs. Regardless of the configuration stack you wish to employ, there's always going to be that one cost associated for configuring and deploying that solution, whether that's internal or you bring in an SI. But again, the stack and suite of tool I've outlined during this webinar, all these items are capital one-time costs. You'll be able to deploy the solution and keep it running free of charge, reaping the benefits of your system for years to come. And down the road, if you wish to extend or stretch that implementation, this IoT for free technology stack will be ready to grow with your company's needs. So that's it for me. I'd like to take this opportunity to thank everyone who actually contributed to the IoT for free stack. We feel providing you with this information will encourage some of you to start taking your own digital transformation journey. And when you do, Sandalwood and Visual Decisions will be happy to assist you on your way. That's it for me, Tim.
All right. Thank you very much for the presentation and all of the knowledge that you shared with us. Couple of questions for you. I know that you were talking about some potential costs at the end in terms of there's no recurring software cost that you'll have on an ongoing basis, but there could be costs for hosting if you want to put the information in the cloud. There could be hardware costs if you're doing it on premise. And then, if you want some assistance, then service cost as well, right?
Yeah, absolutely, right. If you want to push this to the cloud, obviously the stack that I showed, the idea was in an on-prem environment. But as I mentioned, you can push those to the cloud at a certain level. And again, costs are associated with that. And the idea is, taking a greenhouse, for example, there are costs, there's going to be equipment costs, but the software and recurring costs you have control over, right? Mm-hmm. If you, and it's about how fast, quickly you want to scale and in a support level that you desire.
Okay. And who would be most interested in this? I know you talked earlier about kind of small and mid-sized manufacturers. Are there any constraints on that? For instance, given the nature of open source software, are customers better off looking at this if they have some internal resources capable of supporting some of these technical programs?
Yeah, you're definitely going to have some level of technical competency within your organization, right? If you want to take this on yourself. Mm-hmm. That's a no-brainer. There are definitely, it's always a trade-off with open source. They're a great base to build off of, but paid engagements and some paid software, they make things easier. That's their shtick, right? So when you're looking at this, when you're looking at digital transformation, journey that we talked about, right? Those all have to be weighed. And again, you can start this off on your own using open source, and at any point, you can come in and you can bring in other softwares, right? That's part of the idea with using that MQTT abstraction layer. Even if you get your base data collection up and running, you can pipe that to any of the modern IoT systems.
Okay. Let's see. For the less technically inclined, you mentioned that the source code will be available on GitHub. Can you explain what that means to people?
Yes, and it's not up now, but it will be. GitHub is just basically it's a repository. Now I'm trying to think of the best non-technical way. It's a repository for code. So again, you will need someone to go in there that understands how to retrieve that code and actually run it. Not to get too technical, if you're running it on a Linux machine, it's Python 3, and then you put the py extension and run it. We will be also providing what's called a Docker container, which means you'll be able to run it on, with the Docker software, you'll be able to run it on any of the major OSs, Linux, Mac, Windows, etc. But again, that's a technical requirement that you're going to have to invest on your own.
Okay. Let's see, we're at 10:31 here. So any kind of closing thoughts?
So I just want to say a lot of these technologies have been around for a while. It's just in recent years they've been made available to the lower tier, right? And the open source community has started contributing in this area, right? Which again lowers the cost of entry, and it just makes it accessible to more people today. That's a big takeaway. Awesome.
Well, thank you very much. Look forward to anybody that's out there listening to this. Reach out to Frank and I, or either one of us, and we will answer your questions that you might have. Thank you very much.